You're watching InTechnology, a video cast where you can get smarter about cybersecurity, sustainability, and technology.
I'm Camille Morhart. Welcome to InTechnology podcast. Today I'm going to talk with Asaf Ezra. He is co-founder and CEO of the Intel company called Granulate, which offers runtime optimization. Welcome to the show, Asaf.
Thank you, Camille. Happy to be here.
If you had to define runtime optimization, how would you define that?
We define it at Granulate, and why we see it as a differentiation from, let's say, anything that's out there, is the fact that when I was an engineer and I developed code and applications, I tried to utilize the environment to the best of my application. And in here, we're changing it. We're saying, you know what? The application is going to be the same for a long time. In computer time, it's going to be a long time. Why? Because I don't change versions, let's say, every minute, maybe every day. There are like CI/CD pipelines that work every day for certain applications. But a day is a huge amount. And we said, you know what? Why do we need, when we run a production-grade application, to have everything run the same way, whether it's, let's say, healthcare, electronic medical record, or when it's a SaaS platform for cybersecurity? It makes absolutely no sense. And even if it's two different SaaS platforms for cybersecurity, they don't operate the same way. So it still doesn't make any sense. And I think that's changing the runtime according to the application and not the opposite, not building the application according to the specific runtime that I chose. That is why it's so important. And that is why it's very different when you speak about runtime optimization or the application level optimization versus, let's say, a configuration tuning or an orchestration system that looks at everything from the outside in. And the difference between the runtime optimization and the, let's say, application optimization itself is that I don't necessarily know the business logic. So I can't change the validity of the application. So I can't change the order of certain operations. If the order is not guaranteed, for example, when running multi-threaded, if I didn't guarantee the order coming into, let's say, a critical section, that's fine. Everything else has to work exactly the same. So I can't change the way the application works, but I can change the way the runtime provides you the resources with the guarantees that it does.
You're automating this, though. You're going into each application and discovering where there may be a bottleneck, and then trying to free those up by working with the hardware. Is that right?
And this is sort of where the drawback is. Because you have to do it automatically, it's not going to be 100%. So obviously, if every application owner wrote the algorithms of, let's say, scheduling, memories, or whatever, they would have done a much better job. How much better? Whether it's 2x, 4x, I don't know. But by automating it, making it, let's say, scalable, you're leaving some optimizations on the table, no doubt.
Does that automation allow for a customer to set certain levers or preferences? Like, the most important thing to me is performance, or the most important thing to me is to conserve compute power and reduce the overall cost to compute. If it takes longer, that's okay. Do people set those on their own?
Originally, they were supposed to choose like between, let's say, lowest latency and highest throughput, because those two are a lot of time interchangeable. Unfortunately, we didn't think about it ahead of time, but it makes sense to think about applications today as things that already adhere to their SLAs. Granulate comes in usually when an application is already running in production. And when it's running in production, you probably pay enough for it to run at the SLAs that you want it to. For example, I'm looking for a 5 nines latency of X milliseconds. I can always throw more money at the problem, increase the amount of compute I'm using to the point where I'm reaching, let's say, 1 request per core or whatever. It's going to cost me way too much, but just for the sake of example. Which means that most of the times we come in, the organization is already happy with their SLAs, and they just want to maintain those same SLAs at much lower costs. So unfortunately, what we ended up seeing is that people just say, you know what, I'm happy with my SLAs. Can you get me there with a lower infrastructure footprint? And thankfully, like you said, it also improves the sustainability. Unlike, let's say, FinOps tools, where they might end up changing the contract that is related to the machine itself, moving it from on-demand to reserved instance contract. In here, you're actually lowering the footprint. So you're also gaining a lot of carbon emissions reduction. And we give the customer the calculation that we do.
Asaf, you wrote recently about kind of a major change in this industry. Can you explain to us what that change is, why it's transformational?
Historically, people didn't necessarily view Java as like this super inefficient language. I don't know if you know this, but Spark itself is based on of Java 8. So it's already missing a lot of the optimizations that were inserted into the JVM runtime. Now, to sidestep that, a lot of the things that Spark is sort of utilizing were re-implemented and inserted into Spark itself. So they're not relying on the implementation in JVM. Queue in some folks around the world, some of them in Databricks, who maintain Spark, and they're like, you know what? If we had to do everything all over again, this could have been so much more efficient. They chose C++. They could have chosen Rust or something like that because they wanted to be very meticulous about memory management, which is a huge fault. And they also wanted to leverage all those vectorized operations that you can utilize when you're actually doing the compilation. And so they reached an incredible performance improvement. So we're talking on anywhere between 3 to 8 times faster than the, let's say, legacy engines. And this has been hugely disruptive because if you're a managed Spark offering like AWS EMR or HD Insight on Azure or Dataproc on Google, all of a sudden you have something that is like out of this world faster than what you're offering your customers. So it doesn't necessarily mean that it's more cost effective because it could be priced differently, which Databricks is doing. So it's pricing Photon, depends on the usage, but anywhere between 2x to 3x or something like that. But it is a lot faster. So if I'm running a query, I'm going to get it a lot faster. So it might cost me the same, but I'm going to get time. And time is also costly. So if you're any of the other managed Spark offerings, you have to react because otherwise you are going to bleed customers over time. Because even if it's more expensive now, what we see for the past, let's say, 25 years is that compute costs just go down over time. So it could be more costly right now, but over time it will be less. And so the barrier to make the migration is going to be less. How much it's going to cost me, let's say, more in terms of I'm going to have to calculate DBUs, which is the not exactly dollars that you pay on Databricks, but that's their credit system. So it's definitely not something that anyone can have their competitors do and not react. And so this has sort of brought tailwind to Gluten project, which Intel is one of the major backers of, which takes the Velox engine from Meta that they did for their own Presto SQL. It's a C++ engine that runs the operations, and they use a project called Gluten to connect it to Spark engine. And so you'll be able to do something very similar to Photon on certain operations that how many operators that they cover is obviously growing over time. And you have this pull from the market because Ali EMR needs it, and AWS EMR needs it, and Dataproc needs it. And we could be looking at 2024 as the year where all of a sudden data analytics as a market goes down in compute by about, 25 to 50% because of the optimizations done in the back end, because everybody has to react to Photon.
So tell us what role Granulate plays in that back end.
Granulate in itself is built out of multiple layers of offerings. Is that we have an agent running on the machine itself or on the platform itself. So Granulate's agent run alongside the application of the customer, and that would load a runtime module into the runtime. So if we're talking about Spark, we're talking about a JVM module. In this case, written in Java, some sections in C++, and so on. The agent in itself is basically two different modules. One is the loading mechanism that actually loads the module into the application. And the other one is the optimization module. So the first thing that we did since joining Intel, besides branching into the data analytics space, which we haven't done in the past, was to integrate Sapphire Rapids accelerators into Granulate. So now, if you want to benchmark a generation over generation, you're not just benchmarking the CPU itself, you're also benchmarking the system on chip. In this case, QAT and very soon IAA. And so crypto operations and compression operations, and later on memory-intensive operations, where you can do a trade-off between the amount of memory that you're using and the amount of CPU that you're using. Talk about data analytics. A lot of the times we're memory bound. We're not necessarily CPU bound. We might be able to give up a certain amount of CPU, certain percentage, for the same even percentage of memory. And then we're able to lower the cluster because CPU is not the bottleneck at all. So these things are part of the, let's say, the core offering and the ability to integrate more and more into Granulate. And then on top of that, Granulate leverages the ability to understand the performance of the application itself. And when we talk about, let's say, data analytics, we look at the performance of a certain query or a certain job, and then we can change everything according to that. So the scaling, the instance types, the, let's say, amount of executors, the size of the executors, and so on.
Are you doing that, or is Granulate doing that dynamically as it's looking at apps?
So you have to be dynamic because you have to apply it on a per stage, or even in every stage. There's more labor intensive, less labor intensive, more network intensive type works. You might be doing shuffling data and so on. So you always have to adapt to it. When it comes to the computer time, it's almost infinite because of the amount of operations that you can do per second. Comes to the human side, it might look very quick. It's just 30 seconds or just a minute. So how much do you actually gain when you dynamically do things on a per second or per 30-second granularity? And in fact, you're talking about a lot. So the average, just on the, let's say, Databricks side, we're talking about an average of 30%.
That's huge.
The nice thing about it is because Granulate does it dynamically, it's responsible for the loading. You don't need to change anything. So let's say just 30%. It's 30% at the click of a button. Wouldn't you click a button to save 30%? That sounds like a good trade-off.
Who purchases Granulate? Is it enterprises themselves who are looking to optimize all of the different and load balance all of the different applications that they're running, usually in the cloud?
It could be on-premise systems where sometimes you could have huge lead times, and what you need is excess capacity, and all of a sudden you can create excess capacity with software only. In the past, we had to do it with virtualization ratio, with VMware. Now we can do it with Granulate by increasing performance, releasing a lot of the resources back into the original pool, or just keeping some more headroom for growth in the future. And so when it comes to the cloud, the fun thing is you could save tomorrow. You could activate Granulate and immediately shut down machines, so you immediately see the effect on your account. Being able to do that means that I can give the customer any dashboard that I want, but if they don't see it on the bottom line, they're not going to buy. So there's a sort of a good feeling about it because you know that the customer is seeing the value, and you can show them anywhere between a normalization to the amount of throughput that they had and the amount of work that they had to do and the amount of queries that they had and so on. And you see those metrics go up or down, depends on the metric itself. And that's the fun thing about it.
Asaf, do you see any trends coming in the kind of software, hardware optimization space, the interplay between software and hardware?
In the past few years, what we've seen is a huge shift from general purpose solutions into very customized ones. So if you go back to about 16, it was a boom of like customized hardware, especially around deep learning. It happened when it was around machine vision and connected cars and everything. But I think that we're going to see a lot more of that. And we're seeing a lot of hardware companies that are specializing in certain computations. Obviously, generative AI and deep learning are going to be very massive in this space, but I don't think that just that. See things like Graviton that came from the fact that AWS is seeing a huge compute on their RDS, on their EMR, and the compute is very similar. It's worth actually creating a whole new chip just for that specific workload. And I think we're going to see a lot of improvements in the efficiency of the process itself to create a little more customized hardware, similar to the process that we've seen in software. So Granulate, in a way, is taking it another step where you say, you know what? I'm running on a JVM that is generic. How can I make that JVM a lot more tailored to my application? Is it feasible in hardware to reach that level of segregation? I don't know. I have no hardware experience at all. But it's definitely going to go in that direction. And it's going to be cheaper and cheaper and faster to do customized hardware. And I think it's a must. I think, by the way, Gaudi is a really good example for that. You specialize in specific type of compute, and you can make it super cost effective. I think NVIDIA actually released a benchmark that shows that from a cost effectiveness perspective, it's a lot more cost effective to use Gaudi. I think on the cost side, it was like 4 times less or something like that. So those types of solutions, they have to be there. That's on the one side. On the other side, you have, of course, generative AI and how transformational we've seen it when it comes to it's like the world is revolutionary and nothing you can say would understate what they've done when it comes to not only being able to democratize programming, but you can actually do it from an end-to-end app creation. I'm sure you've seen the announcement where now you can create your own application just by talking to an agent or chatting with an agent. If writing applications on top of iOS and Android was something that created, hundreds of millions of applications over time, what order of magnitude are we expected to see now? And what does it mean for, let's say, startups raising money? What are they expected to, or how are they expected to utilize that money when it comes to IP? If now generating a lot of software IP is going to be massively cheaper and massively faster. And I think this is also something that we're going to see impact the ecosystem as a whole, not just data centers or cloud.
What kinds of companies do you think we're going to see explode when the new programming language is English or whatever language you speak in that Google can translate for you?
I think the thing that we're seeing right now is that everyone, let's say, tried to ride that wave very quickly, might have ended up being too fast without good enough moat. So they might end up, let's say, regretting that decision or finding other ways to build a bigger moat. I think what we've seen in the past where usage was the main barrier could still stand. So if I had to guess, I assume that the first mover's advantage that OpenAI had with ChatGPT and the API would still be massive, even though other cloud providers came up with similar API offerings. And I think it's going to go the same way for the foundational model providers. When it comes to the application itself that is going to be on top of it, I think it's a harder question. I think that we are starting to see the obvious implementations but definitely on the B2B side, customer success, customer support, this is finally the chatbot that we've all been waiting for. I think it's only going to go down to who's going to make the migration of policies the easiest. Because no matter how good your NLP model or large language model is going to be in understanding, it's not going to be able to create the policies that you expect your organization to adhere to. One airline company could offer you a refund for something that another company would only offer you like a change for that one. So I think that is going to be one type of, let's say, differentiator, the user experience. It's going to be a lot more important than in the past. So if in the past you could build a better, let's say, technology, I don't think you have that excuse anymore. But unfortunately for actual, let's say, applications that I foresee, hard for me to say, but I expect to see them very fast.
What would you tell people to focus on if they're interested? Like if you look back to when you were thinking of starting a company, the skill set that you may have needed at that time could be pretty different. You might tell somebody to go and learn some programming languages or something, which you're pointing out may be irrelevant very soon. So what would you tell people to become familiar with?
I think the most important part is your analytical skills, being able to analyze the bigger picture and understand and be very honest with yourself about what your differentiation is, what does it entail, what are your, let's say, risks to the business from competitors, internal risks like budget, for example, not being able to reach your goal in terms of development and so on. And at the end of the day, how important that problem is going to be in the next, let's say, 2 to 3 years when you finally come out with, let's say, a general availability level product. And so you have to have a good thesis on the ecosystem, where it's going, and you have to sort of maintain it and update it. Having something like ChatGPT come out while you're planning the future the way that you see it is completely disruptional. And I think nobody can plan for that. But you have to now go and let's say paint a few scenarios where one is it's actually that, let's say, revolutionary thing that I believe it is. The second scenario would be, you know what? It's going to be revolutionary around, let's say, consumer interaction or user interaction. For example, maybe the level that it's going to go to is just on us interacting with products, us interacting with our environment. For example, now my smart home speaker is not going to just be turning on and the lights and turning them off, but it's also going to be my kid's personal tutor, for example, or something like that. So there are other options where you can see it. And the third scenario is, you know what? It's going to be similar to blockchain. It's going to have specific use cases, but it's not going to be that massive transformation that we all hoped it would be.
Asaf Ezra, co-founder and CEO of Granulate, an Intel company that offers runtime optimization. Thank you for joining today.
Thank you, Camille.
Never miss an episode of InTechnology by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.